Let's look at OpenStack's College Physics, Chapter 23, Problem 102. An RLC series circuit has a 1 kilo ohm resistor, a 150 millihenry inductor, and a 25 nanofarad capacitor. A. Find the circuit's impedance at 500 Hz. B. Find the circuit's impedance at 7.5 kHz. C. If the voltage source has VRMS is 408 volts, what is IRMS at each frequency? D. What is the resonant frequency of the circuit? And E. What is IRMS at resonance? So let's write down knowns and unknowns. We know that resistance is 1 kilo ohm. We know that inductance is 150 microhenry. We know that the capacitance is 25 nanofarads. In part A, we're looking for the impedance at a frequency of 500 Hz. In part B, we're looking for the impedance at 7.5 kilohertz, because why not? In part C, we know that VRMS is 408 volts, so we're looking for IRMS at the different frequencies. I guess repetition is the key to learning. In part D, we're looking for the resonant frequency, and in part E, we want the IRMS at the resonant frequency. All right, we have an LRC circuit. It just looks like this. And in the first part, we want the impedance at 500 Hertz, and then we want the impedance at 7.5 kilohertz. So remember that impedance, I'm going to write it up here, is square root R squared plus XL minus XC quantity squared, but XL and XC are functions of the frequency. So I'll solve for them here. X sub L is 2 pi frequency times L. So at 500 Hertz, this would be 2 pi times 500 times 150 times 10 to the negative 6th Henry. So X sub L at 500 is 0.471 ohms. So this is one value that we're going to use. Now, X sub L is at the other frequency, 7.5 kilohertz, will be 2 pi times 7500 times 150 times 10 to the negative 6th. So X sub L at that frequency will be 7.07 ohms. Then we know that. Now X sub C at 500 Hertz is 1 over 2 pi frequency times capacitance, so that's 1 over 2 pi times 500, and the capacitance is 25 times 10 to the negative 9 farads. So we got X sub C to be 1.27 times 10 to the 4th ohms. Then at the other frequency, X sub C is 1 over 2 pi times 7500 times 25 times 10 to the negative 9th, and that gives us an X sub C of 8.49 times 10 to the 2nd ohms. So here we have the different XLs and XCs. So now let's do part A. where we want the impedance. So that is the square root of r squared plus xl minus xc quantity squared. We have the equation right here. I won't copy it over again. So that will be square root r squared, 1000 minus 0.471 minus 1.27 times 10 to the fourth quantity squared. And this impedance will be 1.27 times 10 to the fourth ohms. Then in part B, we're doing the same thing but with different values. So it's square root of 1000 squared minus 7.07 minus 8.49 times 10 to the second quantity squared. And we end up with 1.31 times 10 to the third ohms. Now, in part C, we know VRMS and we're looking for the IRMS. So IRMS by Ohm's law is VRMS divided by the impedance. But the impedance has two different values, so we have to do that twice again. So that's 408 divided by 1.27 times 10 to the fourth ohms. And we're getting 0.032 amps. And then 408 divided by the other one, which is 1.31 times 10 to the third ohms. And that is 0.311 amps. Okay, in part D, we want the resonant frequency. So the resonant frequency is the frequency at which the impedance is lowest and the current is maximum. So that would be 1 over 2 pi square root L times C. So that's 1 divided by 2 pi square root L is 150 times 10 to the negative sixth. And C is 25 times 10 to the negative ninth. So the resonant frequency will be 8.22 times 10 to the fourth hertz. And in part E, we want IRMS at resonance. So let's look at this equation again. To find the resonant frequency means to make the impedance a minimum. That means that we set XL equal to XC. In that case, the minimum impedance will be the resistance in the circuit. So Z min is the resistance, and that means that I max will be the VRMS divided by the resistance. So that's 408 volts divided by 1000 ohms, and that gives us 0.408 amps. And indeed, if we compare this current to the two previous ones we calculated, it's higher.